Friends, my name is Saad and welcome to my YouTube channel. For more content like this, please subscribe to my YouTube channel. Today we're talking about black holes. Now what is a black hole? Now because of the name you can kind of get an idea of what a black hole is. It's black and it's a hole. It's a black hole. That's pretty simple. But what you might not know that black holes do not exist on Earth, but they're actually celestial bodies in space, interstellar space to be exact. So now we're gonna see what a black hole is. Now a black hole, first things first, let's draw a black hole. Now, to be honest, it's very hard to draw a black hole because, well, they're completely black. And you might think nothing is completely black. If you're wearing a black shirt on a cold day, it's still not 100% black, So it's a black hole. So now let's try to draw one. Now, if you're wearing something black on a cold day, it's not entirely black. I already said this, but just repeating. Okay, so now let's draw one. Now, this is a whiteboard, and it will take around 1 billion times what this marker has to provide for me to actually draw one. So let's just not do the black, okay? Let's just not do the blackness. So a black hole is what you will expect, a giant hole. Now, it has more parts to it. First, there's this thing. Okay, to be honest, I have to erase the middle part of the black hole for this to work. Some people might be already seeing what I'm drawing on top of the black hole. And what I'm drawing is, I'm drawing some rings. Now, you might think this is not any ringed planet, this is a black hole. Why in the world should it have rings around it? Well, you'll see. So this is the whole part, but there's another part to the whole part. And that is, there's these ripples. You might think, why in the world is there ripples around a black hole? It's literally black. It's not like you threw a rock into some water. There's no water in space, okay? Also, but it is what you expect. Let's say it's not the thing that happens when you throw a rock at water. It's the thing that happens when you get your finger in water and then take it out. There's a few ripples, very low. Okay, so this is a black hole. Let's erase this to actually understand what the black hole is now. Okay, so first we're gonna see what's the ring part. It's literally a black hole. It's not a planet. It's not an asteroid. A few asteroids have rings. It's not even a moon. A moon sometimes has rings. I don't know. We don't have. That's a video for another day. Okay, so what is the ring part? Now, the ring part is the accretion disk. Accretion disk. I may be spelling that wrong, but okay. So, erase that again. Because the accretion disk is actually much more complicated than you think. First things first. How does a black hole even form in the first place? Now, let's say I drew a star, okay? I drew a star. This is solar flare. This is a random star. Also, let's say it's near the end of its death. So, it's pretty short time. It'll explode right now. So what happens is, let's take a look at its core. When it was young, the core was filled with hydrogen. But now, it's filled with many other things. Hydrogen, helium, and most importantly, iron. It also has iron. Now, there is oxygen, silicon, a lot of stuff here. Nitrogen as well, probably. But iron, all of these produce energy, which keeps the star alive. So basically, a star lives by like this. The core is trying to extend the star, while gravity is trying to push the star to its death. And the core is trying to make the star giant, like huge. So this star and this balance is what makes the star alive. So there's two things can happen. First things first, gravity wins and transforms into, I'll tell you later. But second thing, gravity does not win, and instead, gravity does not win, and instead the star expands and becomes a red giant, and then it explodes in a supernova, which forms another thing I'll tell you later. Now, in the first thing, like when gravity wins out, that forms a neutron star or a black hole. But when it becomes giant, it forms a white dwarf or a black hole or maybe a neutron star, I don't know. Okay, so that's how a black hole forms. Except we're not done yet. When the black hole forms, what is a black hole really? Like, the black hole, how does it even form in the star? It like eats the star inside out. And just as I say eats the star, you may know what I'm talking about. Okay, so it eats the star inside out. So a black hole forms in the core. And then it slowly expands, eats the core, and then eats the star whole. Okay, so, but let's say you're trying to create a black hole without a star. How do you do it? So basically, it's compressing a huge matter of like mass into something very small. So it's very, very dense. It becomes so dense that it becomes a black hole. So to do this, to put that into scale, a black hole the size of the capital city of France, which is Paris, has the same mass as 3 suns. And when you know 1.3 million Earths is a sun and Paris is nothing compared to the Earth, you know how big that is. You have to squish the Earth to the size of a peanut or a coin in order to get a black hole. Just imagine that, okay? For a second. So now, what do black holes do normally? Black holes. So these black holes, they suck up stars. They are so dense that they suck up stars. And just as they suck up stars, they become bigger and larger and larger. Now, if a black hole collides with another black hole, it'll produce an insane, unthinkable, unimaginable amount of energy. So, a black hole. But what about the ring part? Okay, so here's the ring part. It's called the accretion disk. So basically, what happens when a black hole eats a star? Let's say this is the black hole, and this is a star. And you might think, why did I draw this tail of a star? Like, what the heck? This like the black hole sucking up the star. So basically what happens is, after the black hole sucks the star up, there is a few gas and other matter remaining, and that creates the ring around the black hole, which is called the accretion disk. Now, that's basically it, but except there's a weird property. Black holes are so dense that even light, the fastest thing, cannot escape. So that's just giant. Okay, so now there's the event horizon. Event horizon is basically like you get pulled by a black hole outside the event horizon. But, you can't escape the pull of the black hole. But once you pass the event horizon, nothing can escape. You are dead forever. Okay, so you're not returning. So, except there's a weird property. As light cannot escape black holes are 100% black. Like, they do not reflect even a slight little bit of the light. Like, you cannot get that much black. Also, the accretion disks, they are so bright, they are more than billions of stars combined, their brightness. Okay, that's a joke. That's an actual joke. It's much scarier. The accretion disks are so bright that they actually have more brightness than a galaxy, thousands of galaxies containing trillions of stars. Just put that into scale. Something as dark as literally nothing is so bright that it's more bright than many galaxies. Let's take a look at some famous black holes, won't we? Okay. But if we didn't, then, well, this wouldn't be a black hole video. First things first. Let's take a look at the black hole Unicorn. Unicorn is the closest black hole to the Earth. It is the size of Paris, and it does have the mass of 3 suns. So let's actually cut that out again. I don't know why I'm doing so much racing today, but okay, yes. Okay, to be honest, I need to erase this part as well. Okay, great. So now, let's take a look at other black holes. The Milky Way. What is the Milky Way, you might ask? That's not a black hole. I'm just trying to draw the Milky Way. A very bad attempt. This is a very bad attempt to draw the Milky Way. A few stars. Now, every single galaxy has a supermassive black hole inside of it. There are 4 types of black holes. To be honest, there are 3 types of black holes. To be honest, there's 4. 1, stellar black holes, kind of small but kind of big. 2, intermediate-sized black holes, newly discovered. 3, supermassive black holes, they are supermassive. And 4, ultramassive black holes, the kings of the universe. Okay, so every single galaxy, this is the Milky Way, our galaxy that we live in. Every single galaxy has 1 black hole in the center of it. What is this black hole in the center of the Milky Way? It's called Sagittarius A star. It might seem massive since, well, it's a black hole. It's pretty big probably, but in fact it's actually not that big compared to new stars. Like, let's say this is Sagittarius A. Sagittarius, that doesn't fit. I'm just gonna write Sagittarius star for some reason. That's an asterisk, by the way. And here is R136A1, the most heavy star. Not even the largest star. This is not even the largest. The largest star is much, much bigger than this. So, yeah. It's pretty large. It's pretty small compared to other stars. Let's take a look at a few others. Like, we're going to end this video very quickly now because we've kind of reached the end. Okay. Let's talk about Holmberg 15A. Holmberg 15A is a black hole that was the biggest black hole. Holmberg 15A. It was the biggest black hole. Except it now isn't. Because there's new black holes that are bigger than it. Most recently, the oldest black hole that was discovered, not technically the oldest, like the absolute latest, unlatest or something. Okay, so that is Ton 618. Ton 618, it's pretty big, but you may not even realize how large Ton 618 is. I repeated that, I know. So how large is Ton 618? Now, here's the thing. Its diameter is so large. Its diameter is 11 times the solar system. Can you imagine that? It's 11 times the solar system. Like, that's giant. Okay, so let's look at another little... Okay, to be honest, this galaxy is kind of tiny compared to this black hole. It's kind of tiny compared to Ton 618. Well, Ton 618 is pretty big, so you know it's going to be pretty small compared to Ton 618. But Ton 618 is not the biggest black hole. There's a new one we discovered. Now, I'm going to tell you about that later on, but let's see, OJ287. So this black hole's name is OJ287 of the OJ287 galaxy. This black hole is literally the size of the solar system. Okay, to be honest, it's not this big. It's probably like this big. Like, it's very small compared to 10618. I'm just right, not to scale right here. Just a warning to you guys. So now there's one more thing I want to talk about. There is a galaxy. This is the second largest galaxy. Okay, this is IC 1101. IC 1101 is an elliptical galaxy, but the black hole in the middle of it is 40 billion solar masses. That might seem huge, except 10618 is 66 billion. So it is 66 billion solar masses. That's just giant. This is IC 1101. Okay, to be honest, this is not to scale. Everyone knows that. IC 1101 is like giants compared to 10618, like the galaxy. But the black hole inside of it is only this big. Like, it's like this big. Okay? But still small. Now, there were few scientists consider IC 1101, the black hole, to be 100 billion times the solar masses, but that's very, very unlikely. Now, there's another black hole that comes close, but not too close. And that is S5001481. Now, there should be a plus here somewhere. I don't remember where. But this is basically the name. Okay. This black hole comes pretty close, but it's not quite that big compared to 10618. But one black hole is larger than 10618. This black hole has 100 billion solar masses. So it's pretty large. You know that. So what is it? What is it? Guess the name. It is Phoenix A. So Phoenix A is in the Lynx supercluster. Lynx cluster. Like, it was literally like right there, like right in front of our eyes this whole time. Like, it's in the Lynx supercluster. So here's the comparison. Like, let's say 10618 is this big. It's pretty big, pretty large. It's 11 times the size of the solar system. 10618. Now, if Phoenix A is around this big. Okay, trust me, it's not actually that big. It's probably like this big. Okay, to be honest, let's draw it to scale. Also, that's a terrible, terrible circle. So, it's kind of like this big. Like this big. This is Phoenix A. It's Phoenix A. So, but seeing the size of 10618, you might not think 10618 is that large. I mean, it's just a number. 66 billion is large, but you might not know how large that is. Like, 1 billion is large, but we can't comprehend how large it is. So, here's one example. If the Earth was a size of a tennis ball, according to my calculations, 10618 would still be around the size of the solar system, maybe even 1.5 times bigger. Can you imagine that? If the entirety of the Earth compressed into a little tennis ball, 10618 is so big that it will still encompass probably the entire solar system. I mean, it could be a little bit smaller, a little bit larger, but probably will be the size of the entire solar system, or bigger, or smaller. But it's close. And that just puts into perspective how big 10618 is. Now, normally, black holes are pretty tiny, like small, very small. So, yeah, these are a few big, very big black holes. So, basically, black holes are large, and their density is just giant. Now, there's one more thing I want to talk about, and that is the singularity of a black hole. Now, what is a singularity? Let's take a random known black hole, for example. Let's say we take, why don't we take our good friend 10618 here? Because 10618 I've literally been talking about for the half of the video. Okay, 10618. what's in the middle of this black hole? This is the singularity. It's called the singularity. The singularity, this point is so dense that basically it's a zero, like it's a point in space, not even any shape or circle, like any teeny circle. No, it's literally a point, like that small, but it's so dense. Except it is very dense, okay? But I want to give you a scale of how big ton 618 really is. After that, we're gonna end this video, okay? This thing, just see how big ton 618 is, and Phoenix A, and IC 1101, and all the other black holes that are close to ton 618, but not quite. Okay, here, I'll give you an example. This is our good friend, the Milky Way. The Milky Way, very large, right? I mean, surely it's larger than ton 618, right? I mean, it's a little galaxy. Obviously, it's larger than a black hole. Except, well, no. Ton 618 is larger. Now, you might think this is not ton 618, this is some other kind of giant. Well, this is because I drew ton 618 disproportionately. So basically, what I'm talking about here is, not that. It's a little dot. So this is ton 618, the actual black hole part. It's not even that small. It's probably like an atom size. But this is another part of ton 618, the accretion disk. Yes, the accretion disk's this big. Now, if you just saw the rest of the video, you know that this formed because ton 618 ate a lot of stars. And if those stars, a few masses, like 10% of those stars, all of those combined, are bigger than the Milky Way, you don't know, then ton 618 is just giant. Okay, so on that note, on that pretty large note, get the joke? It's large. We're gonna end the video. So thank you guys for watching. Please like, share, and comment, and subscribe. And I'll see you later in the next video. Bye bye.